Okay. Hello, good evening, everyone, and welcome to another episode of our Uncaught Exception mini sessions. We are now at episode 20, I think. And this evening, we'll be sharing about um, Redis PubSub and also the Web Authentication API. So let's get right into it. We'll start with Emman, who will talk about Redis PubSub.
All right. Hi, everyone. So let's get right into it. Uh, Redis PubSub. So let me share my screen. All right. So first, what is Redis? Redis is basically an in-memory data store. It's very famous nowadays and can be used both as a database because it has persistent storage, though it is in memory, meaning it stores data on RAM. Every now and then it writes data on disks, and it can also be used as cache. It has supports a hash data structure wherein you can set key value pairs and get retrieve data very quickly as because it's in memory, and it can also be used as a message broker. Um, and we can message broker and yeah. So today I'll talk about one particular feature of Redis called PubSub. So first, you need to install Redis on your machine. So you can just Google how to install Redis. For Mac users, you can just do brew install Redis, and then you should have it already. And then okay, so to check if your Redis is running, you can just do Redis CLI ping, and you should get Pong as a response. So Redis CLI allows you to use Redis through your command line. You can just do set test value. So this is how you set a value in hash. You can just get that, then you get one, and delete test to delete the value. Okay, so today we'll be using Redis PubSub in Python. So to do that, let's first make our demo directory. So okay, dear Redis PubSub, yes, cd Redis PubSub. Okay, and then let's make our virtual env. Hmm. Uh-huh. Okay, so now we have our virtual env. Let's install Redis. Redis the Python library. Okay, so we can just do it. Let's just write some code right away, because why not? So let's just make a file called demo.py. So first we import Redis, and then we create a client. So it's Redis. And this constructor, I think, receives a host, so we can say localhost, and then port. I think by default, Redis is running at 6379, and then DB, you could just say DB0. And then you can just say client that get test, then we can run it. Okay, none. So let's just uh, open a new terminal, and then um, set a value. to our to see if it's working. So okay, so we're able to connect to our Redis server. So this is how you get value from Redis, and then this is how you set the value. Uh, in Redis. So notice it gets you get a byte instead of string. So you can just, if you want the string, you can just run the decode. Then you should get hi. So this is how you set and get data from Redis. You can use this in your application, maybe use this as cache or even a data store. Because you can also, in Redis, you can list the keys. So here you have different keys that matches the test blob. Okay, so that is Redis setting and getting data, but that's not what we're interested in tonight. We'll be looking into Redis PubSub. So first, to do this, we need to define a function. Let's say listen, and then so we have a PubSub. We define like a variable that uh, stores our PubSub class, PubSub object, and then we make this subscribe to a channel. So a channel, maybe ABS CDN, channel ABS CDN, and then you can just say for message in PubSub that listen. Let's just print the message, and then let's call listen. Okay, so first we receive a message. The first message is for the subscription. Then let's emit an event. Let's publish an event to the channel. So let's say publish ABS CBN. Hello. Maybe hello. When are you coming back? And then here we will receive the message um, as data. So this is cool. You can use this if you, for example, you're running a microservice infrastructure. You can use your Redis service to be your messaging channel to communicate between different services. You can just publish message to a channel, and then other services can listen to particular channels. So then, as you can see, this code is blocking. It's not stopping. So how do we actually listen to um, listen to a particular channel and actually do something else? So to do that, we can use multi-processing. So processing import process. So you can just create a new process class and then point to the listen function and then start it. And then we can do other stuff here. So say for example, I want to send a message every 10 seconds. Let's do import time. So um, while true, it's not good practice. This is an infinite loop, but for the sake of demo, let's just use it. So we can do client dot publish. Publish, I think that was the function. And then the channel name, ABS, CBN, and then our message. So let's just add a counter. X equals 0. Message number x x plus equals 1 and then time that sleep. So let's make it sleep for 5 seconds. Then it just doesn't stop. Alright, let's try it out. Okay, there is a error. Okay, I misspelled client. I used Clint. Who is Clint? Who knows? Alright, there's another error. Hmm, game face. Alright, let's just move this to another function. Let's see if things will be different. Um, and then let's just do it just 10 times. Alright, I don't know why that happened, but moving it to another function made it work. So here we are able to run the part where we listen to the different to the messages on the channel on its own process, so that we can run our other code that we need to do something with. So in this case, we're just testing if by sending publishing messages to the channel every 5 seconds, 10 times. So this is that. Okay. So next, we will look into um, listening to multiple channels. So actually, this library is able to support globs. So say, for example, we can say that p subscribe, p subscribe, ABS asterisk. So it will listen to all channels that starts with ABS. So let's just say we publish on ABS sub X and we test it out. All right, if this doesn't work, so we are able to listen to ABS CBN1 and ABS CBN 2, 3. Okay, so my computer is really slow right now because of the screen sharing, but see, it works. So we can go to our other Redis console. We can publish here the event under message. So ABS GMA. Okay. Hello. And then you'll see here that it is able to receive the message from the ABS CBN, ABS GMA channel. So that is it, I think, for Redis PubSub. A quick demo on how to implement it and use it in Python. So if you have any questions, Shoot, let me know. Arnelle, you're on mute.
Oh, sorry. Thank you for sharing about Redis PubSub. We also have Paulinko on the stream. So if you have questions, feel free to ask them. I actually have one question. Is there a limit to like how many clients can connect to our Redis PubSub? I mean, can subscribe to the PubSub
Uh,
channel?
None that I know of. I think you can subscribe as many to as many channels as you want.
Okay, I see. Um, Looks like no other questions. So we can proceed to the next um, topic, which will be web authentication from me. So let me just share my screen. Okay. Where should we go? Okay, so hello everyone. Welcome to the second session. I'll be talking about the WebShare API. Uh, so WebShare API. Okay. So in the web, we have sites that allows us to like log in, right? So do authentication with either email or password, and we usually add two-factor authentication to that to make our accounts more secure. So we have different options for two-factor auth. One would be SMS, where the user receive an SMS with a code that they can input on the site to verify that they actually have the phone with them that's registered to the account. Another one is through like authenticator apps like the Google Authenticator app or like Microsoft Authenticator. I don't know. There are many of them, which generates a code every minute or two, and that's what you use to log in. That's what you use as a second factor auth to log into our accounts. Another option is through security keys, which looks something like this. So there are actual physical devices that you plug into your um, laptop or computer, where after you input your username password, you have to physically tap them to verify that you have actually have the device with you. So that's one thing. And what we are going to talk about is about that last option, security keys as a two-factor mechanism for our websites. So here, okay, this actually currently doesn't work. Uh, so let's take a look at uh, a sample like um, flow of using the Web Authentication API. So there's a really cool demo by Auth0, the authentication service that you've probably heard of, in the URL WebAuthn.me. So it shows us, wait, let me hide my terminal. So it shows us like the step-by-step flow of how web authentication works. So, so here, this is assuming we are signing up to our account. So this could be whatever website. So you input your username, your password, whatever other information needed to create an account, and then you click on register. So usually this is not done automatically. You have to create an account first, and then you have to go to your account settings to set up two-factor auth, right? But for the demo, it's done automatically. So let's do that again because I ran out of time. So after you register your account, and then, oh no, it's not loading anymore. So after you register your account, you go to the settings page, you enable two-factor authentication, which could be either SMS or in our case, our security key. and will go. So the browser will contact the server about it, and then basically you will be prompted to like physically tap on your security key. So it just happens mine has a pin. So I have to add it. That physically tap on it. So that's how I verify that um, I have the device with me. So that's my two-factor authentication. So we'll discuss these different flows in a bit. So now in my account, that credential from my security key is now associated, saved in in the database somewhere, and associated with my account. So the next time I log in, so for example here, I try to log in, I input my username, password, and instead of receiving an OTP, I like an SMS OTP, I will be prompted to physically tap my security key. So here, and that's how I verify that it's actually me having the security key device with me. So that's a basic flow of how it works. So let's um, go through each one of them step by step. So what's actually happening here? Okay, sometimes the demo site has issues, so let's do that. So first time, you create your account. So you sign up to the website, you input your name, password, whatever, and then two-factor auth is not automatically enabled usually. So you have to go to the settings, and then you have to enable two-factor auth or like security key as the two-factor auth mechanism. So once that's enabled, the browser will have to contact your backend. The backend will create a challenge. So this will be like a random string, basically, that your authenticator device needs to encrypt. So what happens here is that the authenticator device will create a key pair. So if you're familiar with it, it's like a public key, and then there's a private key that it's stored on the device. And then um, the device, I mean, after you tap on the device, the public key will be used to like encrypt the challenge, send it back to the backend, and then once the backend verifies that it's correct, then that's how it will like successfully register your um, security key. So let's do that again. So usually security keys, I mean, the Web Authentication API it times out after a few seconds if you take too long to tap your security key. Let's restart. So what's happening here again? I click register, or like I set up my authentication key. The relying party, that's what they call the website that will take care of all the authentication and verification of the users. So once you click register, the browser will ask for the challenge. Your backend will generate the challenge, which is whatever it is, and then it will ask for the public key from our authenticator. So once we tap on it, you see the public key and the ID for your credentials is sent to the backend. And once verified, like this, once verified, these are all stored in our backend's database, so that later, when we log in, we just ask the user to like verify using these credentials. So try that again. So now this is now registered. The next step is to log in. So when we do log in, that's when we type our email, username, password, right? So email, username, password, then click on login, and instead of getting logged in right away, the relying party or our backend first needs to verify that first needs to do like two-factor authentication. So verify that it's usually either SMS or in our case that we have the security key. So again, when we log in, we send username, password. Again, the backend will send another challenge that we need to like pass in our authentication in our authenticator by like encrypting it with the private key. So stop it. Oops. Okay, so now that we've signed the challenge, or like we've encrypted the challenge with our private key, that gets sent back to the backend or the relying party, and then it gets verified if okay it's signed with the correct private key. This must be the correct user, and that we are logged in successfully. So that's how the flow works. Let's see it in an actual like sample, like in terms of how to actually code it. So so I have here a sample site that is at the moment not 100% functional, but let's just see. So here we register an account like we always do on the internet. It's taking so long because my database is not on my local machine. And so usually after we register, we get signed in, and then we can go to like a settings page somewhere where we set up two-factor authentication, right? So maybe I've done this before where you set up SMS authentication or an authenticator app. But in our case, we're going to set up like web authentication devices. So there are actually two kinds of authenticators that we can use. The first one is what we call roaming authenticators, or like cross-platform authenticators. These are like physical devices that are usually in like USB devices that you can plug into whichever device you want to log in from. So what I have here is like a YubiKey something security key. There are other ones that are out there like the Titan security key from Google, I think. And the second type of authenticator we can use is called the platform authenticator. These are authenticators that are integrated in the device that we are using. So this is usually common in mobile devices. For example, in Android or iOS devices, they usually have fingerprint sensors that we can use to unlock our phone. That can be used as an authenticator also. Or if you are using like the MacBook devices with the fingerprint nothing, the device, you can use that as a platform authenticator also. So in our case, let's try to set up a roaming authenticator. So how does it actually work? So there are in Web Authentication API, there are two parts that we need to work on. First is on the browser side, which is actually calling the Web Authentication API, and also in the backend side, which is like verifying like the public keys and everything, and then actually storing them to the database. So for the backend, I'm not really familiar with it because I don't know how to verify all the different like formats from different like from Apple or like Android devices. So we're just going to use a library called Simple WebAuth. This is available for Node.js, and actually this also has like a browser side library, but for the sake of demo, we'll make things more difficult and do everything ourselves. So we're just going to use the server side of Simple WebAuthn. So going back, how does the API actually work? Go to our console. So the Web Authentication API is available from navigator credentials, and from here we can create or get our existing credentials or create new credentials. So to create a new credential, this is what we do when we register. So so this is the credentials management API, and the Web Authentication API is actually like an extension to the Web Credentials API. Before, we can use the Credentials Management API to like store passwords into like the browser, and also like we can use that to retrieve it later, so we can automatically log in the user when they visit the site on another device. So that's credential management API is like available for a long time already. But in order to use Web Authentication API, we need to use the Credential Management API, but with a public key option. So here we need to provide options for like creating our credentials. We can check MDN for all the options. There are two things. So the first one, when we are trying to create like a credential, we use navigator.credentials.create, and we need to pass in these options. So we'll just follow each one of them. So RP, what's RP? Let me move this. I'm sorry. So RP is the relying party, or this is the URL to our backend. So RP, let's just use localhost, or like not the URL, but the host name of our backend. Next is user. So this is information about the user, because the credentials will be stored on the browser. So, I mean, on the authenticator device. So we need to provide information about the user. So ID here needs to be a buffer, I think. So I'm just going to put in a new array buffer. Let's just make it 5. So you need to provide actual values here, but for demo purposes, just do that, and then provide the user's name. Next. Next. What else? Okay, because I don't remember everything. Let's just take a look at what we get here. So I'll just copy paste the data that it gives me here. Okay, copy. Okay. I lost my code. Credentials that create. It needs to be from P, and this needs to be passed here. So let's just format it properly so that it's readable, and we're missing commas. Okay, extra credentials. Okay, let's just then I forgot the commas. Okay, hopefully this should work. But these are different options you can do. Attestation, I actually don't know what that is, but we can check here. Attestation, which indicates how attestation should be transported. Okay, I don't understand. But these are already provided by the simple WebAuthn like server side and library. But anyway, the important things here are the challenge. So this is something randomly generated by the backend. So when we send it back, when we send our credentials or like signature and our publicly back to the relying party or to the backend for like verification, it's going to check the challenge. Exclude credentials. Currently, it's an empty array, but normally this is used when you want to register another security key. For example, you have 3 security keys. You've already registered 2 of them. You want to register the third. You probably want to exclude the first 2 already so that they're not detected by the API. So pub key, cred params, these are different, like what do you call them? Like different encryption algorithms like RSA, whatever. So each number here, -8, -7, they correspond to different like algorithm. And RP, this is information about our relying party, or like the backend that's going to do all the things. So name, whatever we want to call it, and ID, which should match the host that we are running the site from. Then timeout, this will just be how long the API will wait for us to tap on the device. So let's run. Okay, I forgot to create array buffers. How do you create array buffers? So I'll just new array buffer. That should work. And what should be array buffer? Okay, let's try. Oh no, user is required. Yep, we forgot the user. Um, add it. User ID. This can be whatever identifier we have for the user in our backend. So if we're using like numeric user IDs, we can use that. If you have user UID, I mean UUIDs, we can use that. Oops, array buffer, whatever. But it should be like an array buffer representation of the user's ID, and let's give it a name. Could be me. So run. Oh no, display name is not defined. Yeah, it should be display name. Oops, misspelled it. Okay. Oh no. Yeah, I should have added both. um, this is okay. So here, let's try that again. So this is the actual web authentication API call. So basically, we just have to provide all these options. In an actual app, these options will not be generated on the browser, but from our backend, especially because we need a challenge, and also we need information about the current user. Okay, so let's run that. After when we run this code, this will ask us. This will automatically check if there are like security keys connected to the device. So if I unplug it, which you can see that I unplugged, it will just say that okay, there's nothing connected. But if I connect it, okay, then we have to tap it, and then it will ask for permission if we want to use the security key for this site. And here we get our public key credential. So, so this will be our raw ID. I mean our raw ID in string format, and here's the equivalent in as an array buffer. We have all these are array buffers, but basically this contains information about like the public key and other information. But what we need to do is we need to send this public key credential to our backend. So just use XHR or Axios or whatever we use in our app to send it to the backend. So that's actually what we are doing here. So if I click this, the backend, if it works, okay, the backend will create all those options for us, send it back to the front end. Front end will call the API. The API will ask us to verify the security key. Once we verify, we get the public key credential object, and we just encode it or serialize it. Oops, I need to tap, sorry. Serialize it and then send it back, and then send it back to the backend for verification. And once verified, it's stored in the database. So far we've seen the front end side of the API. Basically, it's just the navigator that credentials that create call. So how does it actually work in the backend? Because this is also another like aspect of using the WebAuthn API. So, oops. Okay. So, as I mentioned, we are using the simple WebAuthn library. And for the server side, and it already has functions to generate like attestation options and verify attestation response. So what is attestation? What do they refer to with attestation? The attestation is basically just these options. So that's basically what it means. So generate attestation options means generate this. It's basically make sure that you have the device that you want to register to. So using the API is easy. You just call it, provide the different options that you want to use. For example, the relying party's name, the relying party's ID, they all end up in the generated options. The user ID, yeah, why were the user not here? Anyway, so and the user ID and the user's name and the user's display name and the attestation type, and then it will generate these options. And then that's what we send, that this is what we send back as a response to our front end or to the browser. And again, this prompts us to tap the security key. Once that's verified, we get the public key credential and we send it back to the backend. So here is how we verify the public key provided from the security key. So just call verify attestation response, and then we pass in the actual credential that was generated when we tapped on the security key. We pass in the expected challenge, which was the original challenge that was generated here, and then that's going to be used to verify if like it's signed properly, something like that. And then expected origin, which is just our website's origin, and then the relying party's ID. So that's it, and it will tell us if it's verified or not. And once verified, yeah, we should have like I should have added like extra validations here, but I mean error checking and stuff. But once it's verified, we can store it in our database. That's what create credential does, and that's the end of registering a credential. That's a lot of stuff. Did I successfully register a credential? So once that's registered, it can then be used when the user logs in to our app. So let's try logging in, and here, if this works. So my email and password correct, but as an extra authentication, I need to tap on my security key, such as a pin. So this won't work because I messed up something in the code for now. But the idea is, how does it work? Oops, sorry. Come on, browser. Okay, so the idea is, in order to get a credential, again, our server needs to create options for the Web Authentication API. So before, attestation is when we want to register an API, but when we want to register a security key. But when we want to get like an existing credential from a security key, it's called assertion in Web Authentication. So simple WebAuthn already provides us these options, so we can easily use them. But the idea is, once we receive those options, again, we need to call, okay, the keyboard just froze, navigator, that credentials, that get. So if you want to use existing credentials already that we've registered previously, we need to use the .get method. And we need to pass in like additional options again. Not credential challenge as before. When we want to assert that, okay, maybe I shouldn't have used assert, but when we want to like get an existing credential from a security key, the backend will again generate a challenge. We need to pass that as an array buffer. So you won't actually do this, but because I don't know how to convert strings or buffer, we'll just hack it like that. The other thing is, what's the other thing? Okay, if when in doubt, check the docs. That get public key request. So aside from the challenge, we need to pass in allow credentials. So these are the different credential IDs that we've stored in our database. So because this is stored in the database, we can easily query them and then include them here. So allow credentials. Oh, no, this is an array. So for example, if the user has registered 5 security keys, then we have to pass all of those in the allow credentials, and then the browser will look for like those credentials. So credential has an ID, which needs to be an array buffer again. Okay, and this other thing, credentials, an ID and a type, yes, and a type, and it's just a public key. So this worked. Okay, so this worked. We should have passed user verification also, but it's fine. So what happens here is once we call navigator.credentials.get and then pass in these public key and options, the browser will look for like authenticators that will match those credentials. So it found mine. So I need to pass in this. So that's it. And once I verify, but won't work because I just passed in dummy values, we will also again get another credential object like we did when we registered our security key. And again, we need to pass that back to the backend and then call verify assertion response, which just pass in these options, and then it will check for us if the credential given is valid and verified. And once verified, that this is where we actually log in the user because they've proven that they are who they say they are. So that's WebAuthn. And what else? Yeah, so some resources, of course, MDN. And if you want to know more about the API itself, all the options that we can use are available here. Actually, there's one more thing. Let's see. Okay, I'll get back to that. So MDN for all the options and stuff. And for if you're using Node.js as your backend, a really nice library that I found is Simple WebAuthn. It has support for the server side to generate like attestations and assertions, but actually it also has like a companion browser side library, which we didn't use because we wanted to call the Web Authentication API ourselves, but this definitely makes life easier. So instead of going through all like figuring out the different options and then converting them to array buffers, we can just we can just do start attestation and start assertion somewhere here. And it will do all the cleaning of the data and then calling the Web Authentication API for us. So yeah. And for the demo, again, webauthentication.me from auth0, just to play around with like your security key. And actually, yes, one more thing. Let's see if I can find it. I think it's authenticator selection. Okay, so when you call navigator.credentials.create, and I think also navigator.credentials.get, you can pass in the authenticator selection option in one of those as one of those options. And this is an object. There's an authenticator attachment property. So it can either be platform or cross-platform. So when we say cross-platform, again, it's those like physical devices that you can plug in anywhere to authenticate. But just by changing this option to platform, all the options can remain the same. It will also automatically tell the Web Authentication API to look for like built-in authentication devices like the fingerprint like sensor or like the touch ID in like some Apple devices that are already like integrated into the device that the user is using. So this is the only change we need to do um, to like use either roaming or platform security keys. And that's pretty much it for uh, this talk about Web Authentication API. So I'll definitely try to finish this demo and then post it online when it's done and all the issues are fixed. But for now, that's it. And if you have questions, feel free to ask them.
I have a question. Um, is there something like course for this? Because you can specify the host, right? As part of the payload when you authenticate. What if you just spoof it? Like it's for some other website or something. What, what is there a potential issue with that?
Yes, good question. Uh,
Like
so,
what if
I mean, yeah, you go.
since it's from the server, what if I'll just put in the host or whatever the key was, I just say Facebook or something like that.
Yeah.
Facebook.
So you can do that, but then again, you have to figure out what the challenge. Yeah, but the challenge is passed as part of the responses. Yeah, yeah. I don't
Yeah,
know.
it's just that it will be stored in the key in your UB key, but it's for Facebook, but it's really not. So in
Okay. So the API as like part of the verification is it actually checks um, the the origin and things like that of where like the request is from. Although you can still provide that when you like manually send the request. Um, I'm not sure. You
does
are
it have
muted.
something like course or something? Because like you can prevent like spoofing right on web by using course headers in the server. So JavaScript cannot send a request to your server if it's not from the right host. Is there a course as well uh, this API wherein you can't set the host if it's not running on the same domain, something like that?
It's so the API. So the API part, like getting the options, sending back the public key back to the server. That's all REST currently. So we can use like existing. Um, we can use like existing like best practices in terms of like course for REST API. The Web Authentication API is really just um, the device, plug it into your laptop, and then the browser API call that will um, check if there's an authenticator device plugged in, then get the credential object, and then passing that back to the browser is again, I mean, to the backend is again just normal REST APIs, nothing special there. So whatever we do for existing REST APIs in terms of course, we can apply the same apply the same practices here. Did that? I'm not sure if that answered the question.
Yeah. But the main question is like, is there like any merit if like for a malicious person to spoof the host part of the payload for the authentication?
Um, I'm not sure I understand still. can you can you elaborate?
Like for example, the one we set like localhost a while ago. For I think it was RP or PR. Is that
Yeah, RP.
so? RP. Is there any merit if like I spoof in my because I'm a malicious site and then I don't use my correct domain and then I use someone else's. Is there any merit to it? Like what could I possibly gain if I do that?
If you do that, but it will only just affect you, I think, because um, even if let's say you send like a request like from a different origin or maybe through your terminal, you'd have to pass in like the public key and those other like required data, right? But you'll only be passing your own. So if you're saying I spoof, I mean, I send a request manually, like from my terminal, and then even though it's from my terminal, not from the app, and then if find a way to like pass in the correct options, like public keys, the different, like the other, I don't remember all the data you get from the credential, but the credential ID, the public key, those will just be your public key. So it will only, I mean, I'm not sure if you can like affect other users. You'll just be messing up your own account. I think there might be other reasons, but that's all I know for now.
Okay. But
Thank you.
you can use the same YubiKey, right, for multiple accounts for the same host.
Um, depends because I remember earlier you can. It depends on the site because remember one of the options when you create a credential is like the exclude credentials. So if the site provides those, and then it will exclude existing credentials already, then um, then it will the security key will create a new like key pair um, for for that like request. And also I think if the user information is different, like a different user ID is for different user, um, I'm not sure, but I think a new key pair will be generated also. I mean, we can check that. I mean, we can verify that in a demo if like creating, I mean, checking the generated credential for different users if they're the same or not. But I haven't done that, but I think they're going to be different.
Okay, that's all my
Thank you,
question.
Eman, for the difficult questions. So yes, I still need to do more demos with this. Those things also need, yeah, I need to like check on them because I've never checked on them previously, and I still need to finish this existing demo. But we'll see. Let's see if we have other questions. Um, Looks like we have none.
None.
I think
Yeah.
I don't see anything. Someone said hi.
Sad.
So someone said hi in the comments. Hi, Mud. So I don't know how to pronounce your name. Hi, Madhuri something. Um,
Shout out to you.
and Pao is also here. If no more questions, I think we can wrap it up. We're like here for like an hour already. So thank you all for all the maybe Eman you can mute. Thank you all for everyone who like watched the stream, and if you have questions after this, just feel free to ask them. We'll answer them in a future time. And again, um, that's it. Please subscribe to the channel, like the video, and um, that yeah. See you next time.
See you next week.
Bye.
Bye.